Hi everyone, welcome back to my channel Chiru's Aspirations. Today I am back with an amazing concept, that is pair of linear equations with two variables. Already we have completed two chapters, that is real numbers and polynomials, and today we are going to see what is pair of linear equations with two variables, how to solve all those things. The people who are new to my channel, hi, this is Chiranjeevi, I am a maths trainer. So today we are going to learn this, a very interesting and amazing concept. So a polynomial or a linear equation, if you consider, the equation with the degree 1 is called as linear equation. Without equating that, then that becomes an expression. When we equate that, that becomes an equation. That is the difference between an expression and an equation. So here, if you consider, for example, ax square plus bx plus c, that is equal to 0. Here, this is a quadratic equation because I have equated to 0. If I take out this equal sign, this becomes expression. Similarly, here, whatever the polynomial you take, so if the degree is 1, here, as I took ax square plus bx plus c is equal to 0. This is a quadratic equation. Here it is a single variable, only x we can see here, and the highest power was a degree. So you can take anything like ax cube plus bx square plus cx plus d. This is the format it will be going on. Whereas when coming to a linear equation, we'll be having degree 1. Likewise, ax plus b. This is a linear expression, and if that is equal to 0, that becomes linear equation. In this chapter, we'll be seeing intensively about the pair of linear equations with two variables. Here only one variable x we can find, whereas a and b is constants, and a is the coefficient of x and b is a constant. But when we come to pair of linear equations with two variables, then a condition arises that a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0. These are the two equations arises when we consider pair of linear equations with two variables. So here we have a variable x and we have a variable y. Here also we have a variable x and we have a variable y. C1, C2 are constants. Also a1, b1 and a2, b2 are constants. But whereas a1 is the constant, is the coefficient of x in the first equation, b1 is the coefficient of y in the first equation, and c1 is a constant in the first equation. Whereas coming to a2 is the constant of the x, a coefficient of x in the second equation, b2 is the coefficient and constant of y with respect to second equation, and c2 is also constant with respect to second equation. So two equations will be having. So this is the general form of pair of linear equations with two variables. Having linear equation, if we plot graphically, so we cannot get a particular value or a solution. So whenever such type of criteria arises, we'll be having two equations so that we'll be getting some solutions. So it is related to real life problems, like whatever the situation we have in the real life. So we can convert that in the form of linear equation, and obviously we can solve it. So solving pair of linear equations in two variables, we have two methods. First one is the graphical method and other is algebraic method. So today we'll see some essence and some basics about the graphical representation of pairs of linear equations, and in the coming videos we'll see what are the algebraic methods of solving a pair of linear equations with the two variables. I hope you people are understanding. Yes, let's go for that. So we were speaking about an equation, that is a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0. These are the two equations we have. Now whenever we take the coordinate system, this is x-axis and this is y-axis. So x dash and y dash. So this is the origin. So in the coordinate system, when we start plotting a linear equation always will be getting a straight line. Whatever may be the linear equation we are going to plot in the graph, so any linear equation will be of straight line. Okay, so here a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0 is the general form. So if we start substituting or taking some values for a1, b1, c1, a2, b2, c2, then we'll be getting straight lines. So always a linear equation gives a straight line, whereas a quadratic, it is a parabola. So here we are intensively discussing about the linear equations with the two variables. So these two equations will be of straight line. So it will be somewhere in the coordinate system we'll be getting some straight lines like this, something like this. So all the straight line you will be getting with respect to this thing. So if we consider particularly these constants, these constants you have, right? What are the constants you have in the first equation? Let me take this as first equation and this as second equation. So in the first equation we have constants a1, b1 and c1. In the second equation we have the constants a2, b2 and c2, right? Now we are going to see what is the relation between the coefficients of x, y and constants. So let's see the relation between these constants, that is a1, b1, c1, a2, b2, c2. Okay, so when you separately take, for example, a1 by a2, if you divide a1 by a2, b1 by b2 and c1 by c2. Let me take the first condition, a1 by a2 and b1 by b2. So here a1 by a2, this one a1 by a2, the constant of the coefficient of x in the first equation and the coefficient of x in second equation, a1 by a2 and b1 by b2. These two constants I am taking and I am comparing it. What is the relation between this, that is a1 by a2 and b1 by b2? The relation is very simple, that is they are not equal. The first relation I am telling, they are not equal. In the sense, if a1 by a2 is not equal to b1 by b2, then in the coordinate system, you will be getting two lines which is intersecting at one particular point. Okay, so if the constant a1 by a2 is not equal to b1 by b2, then these two lines, when we plot on the graph, the two lines will be intersecting and you will be getting unique solution. So you will be getting unique solution, which means only one solution. Whenever, let me take this as equation 1 for example and equation 2, when these two intersect, and if we take like this, then this will be the y value and this will be the x value. So you will be getting both the values x and y when this intersects here. I hope you people are understanding. So unique solution, only one solution, one value of x and one value of y, will be getting only unique solution. Here at this point we will be getting the values for this particular thing. If at all a1 by a2 is not equal to b1 by b2, we will be having unique solution. Geometrically the two lines intersect and also it is consistent. If you check the consistency, this is consistent. What is the meaning of consistent? Consistent means the solution will be getting some solution, so that when we substitute that solution in the equation back, the equation will be satisfied. So here we will be getting a unique solution, so this is consistent. Let us see another relation, what is happening between these constants. So if a1 by a2 that is equal to b1 by b2, that is not equal to c1 by c2. See, first relation was this and second relation is this one. a1 by a2 that will be equal to b1 by b2, but it will not be equal to c1 by c2. In this case, what's going to happen in the ordinate system, the coordinate system, x and y if we take, so we are going to get the parallel lines. if this is equation 1 and this is equation 2, so we'll be getting parallel lines. So whenever we get a parallel lines, then there is no solution. What about solution? No solution. The lines are not touching, right? If at all, if we take the coefficients, these constants with respect to these two equations, and if we get a relation like this, which means a1 by a2 is equal to b1 by b2, that is not equal to c1 by c2, then these two lines will be a parallel lines. So nowhere it will meet. So there is no solution. So about consistency, it is inconsistent. It has no solution, right? It is inconsistent. Coming to other relation, we have a1 by a2 that is equal to b1 by b2 that is equal to c1 by c2. All the three constants will be equal. If this is the case, then in the coordinate system x and y, so one line will be getting first equation, the same thing it will be overlapping on the same line, that is second equation. Two lines, two equations, two lines. So two lines will be overlapping and coinciding on each other. Now what about the solution? Whenever we get this case, that is a1 by a2 is equal to b1 by b2 that is equal to c1 by c2, then two lines overlap or coincide with each other. Then solutions, it is infinitely many solutions. Infinitely many solutions. Right? This is a solution, this is a solution, this is infinitely will be having many solutions if this is the case. What about consistency? It is consistent but with respect to some point. So all the solution we cannot take, right? So this way we have three relations with respect to the linear equations in two variables, pair of linear equations in two variables. The first relation is a1 by a2 is not equal to b1 by b2, then the graphically if we represent two lines will be intersecting, it will be getting a unique solution and it is a consistent. When a1 by a2 is equal to b1 by b2 that is not equal to c1 by c2, then the lines are parallel and no solution. It is inconsistent. When a1 by a2 is equal to b1 by b2 is equal to c1 by c2, then the lines overlap or coincide with each other, so that we'll be getting infinitely many solutions and it is obviously consistent. I hope you people are understanding. Let's go for problems. So what's the problem? Okay, let me take a problem. So first problem, x minus 2y plus 5 is equal to 0, 8y minus 4x plus 20 that is equal to 0. So these are the two equations they have given. So the question is, verify the relations between that and tell whether the lines intersect, overlap or are parallel. So these are the three conditions we should check. Now first solution we are going to consider these two equations. So considering equations, we have x minus 2y plus 5 is equal to 0, and I am going to arrange this minus 4x plus 8y plus 20 is equal to 0. So these are the two equations. So this is a1, b1 and c1 with respect, if we take the general form, a1x plus b1y plus c1, a2x plus b2y plus c2, that is equal to 0, right? So we are going to consider with respect to this. Here a1 is equal to 1, b1 is equal to minus 2 and c1 is 5. a2 is minus 4, b2 is 8 and c2 is 20. Now a1 by a2 is minus 1 by 4, right? b1 by b2, that is minus 2 by 8. If we simplify, again we'll be getting minus 1 by 4. and C1 by C2, that is equal to 5 by 20, obviously it is 1 by 4. So we got A1 by A2 is minus 1 by 4, B1 by B2 is minus 1 by 4, and C1 by C2 is 1 by 4. If we take this, if we compare this, see A1 by A2 is equal to B1 by B2 but not equal to C1 by C2. So by seeing this, by observing this, so by comparing the ratios, we have A1 by A2 that is equal to B1 by B2, which is not equal to C1 by C2. I told you three conditions. The first condition was if A1 by A2 is not equal to B1 by B2, then the lines intersect. So if A1 by A2 is equal to B1 by B2 and that is not equal to C1 by C2, then the condition is they are parallel lines. So therefore the pair of equations are parallel to each other. So there is no solution for these two equations, and also they are inconsistent. I hope you people are understanding. So I have just taken the ratios and I have just compared the ratios. So this is the final criteria occurring, that is A1 by A2 is equal to B1 by B2, that is not equal to C1 by C2. Then if this condition occurs, then obviously it is parallel lines. So when there is parallel lines in the graphical representation, so it does not meet and will not get solution, any solution. So these two equations, that is x minus 2y plus 5 and minus 4x plus 8y plus 20, these equations we cannot get a solution, they are parallel lines. I hope you people are understanding. Let me do another problem. Okay, so this is the problem. Now these are the two equations for the solution. So first we'll consider the equations, that is 3x minus 5y plus 8 is equal to 0 and 7x plus 6y minus 9 is equal to 0. So we'll compare the ratios. Here we have A1 is equal to 3, B1 is equal to minus 5, C1 is equal to 8, A2 is equal to 7, B2 is equal to 6 and C2 is equal to minus 9. This is minus 9, right? Yes. Now I am going to take A1 by A2. What is A1 by A2? That is 3 by 7. I cannot simplify further. It is in the simplest form itself. So B1 by B2. What is B1? Minus 5 by 6. I cannot further simplify this also. It is in the simplest form. C1 by C2. So 8 by minus 9. This is also in the simplest form. So if these three, that is A1 by A2, B1 by B2, C1 by C2, three are of different values. So no need to worry here in case of this, all the three values are different. So here the first case itself, we can tell that A1 by A2 is not equal to B1 by B2 by comparing the ratios, right? So therefore the lines intersect at a point, and it has unique solution. So I hope you people are understanding. I have taken just the equations, taken the ratios and just compared. Here 3 by 7 is not equal to minus 5 by 6. Hence A1 by A2 is not equal to B1 by B2. So I told in the first condition, if a1 by a2 is not equal to b1 by b2, then these lines, what happens in the coordinate system, they intersect and some particular unique solution will be getting. So therefore it has a unique solution, it is consistent and the lines intersect. I hope you people are understanding. Let me do the final problem for today. Yes, so these are the two equations. We have 4x plus 3y minus 7 and 12x plus 9y minus 21. Similarly, for the solution, what we are going to do, considering equations. What we have, 4x plus 3y minus 7 is equal to 0 and 12x plus 9y minus 21 is equal to 0. So here, look at it, the x should come in the same place, y and the constant. Okay, be careful in arranging. Sometimes if it is mixed, make x in the first term and y in the second term. Okay, so here a1, the coefficient of x is 4, b1 is 3 and c1 is minus 7, a2 is 12, b2 is 9 and c2 is minus 21. So now I am going to take the ratios, that is a1 by a2, that is nothing but 4 by 12. So for 1s are 4 3s are, will be getting 1 by 3, that is a1 by a2. Next b1 by b2, that is equal to 3 by 9, 3 1s are 3 3s are, so that is 1 by 3. Again b1 by b2 I am getting 1 by 3. Next I am going to take c1 by c2, that is equal to minus 7 by minus 21. Minus minus gets cancelled. 7 1s are 7 3s are, that is 1 by 3. So what happened if you observe? a1 by a2 is 1 by 3, b1 by b2 is 1 by 3, c1 by c2 is 1 by 3. So therefore, by comparing it, a1 by a2 is equal to b1 by b2 is equal to c1 by c2. If this is the condition, then what I have told initially, then the lines are coincident. That is, therefore, the lines are coincident, which means in the graphical system a line and again same line will be coming on that, so that it has infinitely many solutions and it is of course consistent. I hope you people enjoyed this class and understood. We have solved 3 problems related to this one, and how to represent this graphically I'll be coming up with next video. So all these 3 equations, same equations or some other different equations, I'll be coming up with the graphical represent. Let me take the same equations and show you. So how a1 by a2 will be equal to b1 by b2 will be equal to c1 by c2, and that will be equal with respect to graphical representation. I'll be coming up with next video. So plotting the graphs and showing you how these conditions are satisfied with respect to same equations. I hope you people enjoyed today's class, that is pair of linear equations in 2 variables, the introduction, the general form, and also comparing the ratios and constants of x and y, these 2 variables, and seeing the relations, what is happening between the constant, the a1 by a2, b1 by b2 and c1 by c2. Yes, so I hope you enjoyed today's class, and I'll be coming up with many other videos. So if you like this video, like it, share it and comment. Don't forget to subscribe my channel, so you will be getting notifications of these mathematical concepts. So I hope today you have enjoyed this mathematical concept, I'll be coming up with cbse all the chapters, and later on I'll be coming up with the fascinating science concepts also. And in my later on videos I'll be coming up with the NCERT exemplar problems also. So subscribe my channel to get all those notifications. I hope you are mathematically inclined. Bye. Take care.